All right, this is the introduction to Unit 4. This is 4.1, an introduction to polynomial functions. The two things we want to take care of today is to classify polynomials and use the calculators to make polynomial models. If you're watching this video, you probably won't be able to do that second part, but we'll cover the first part pretty well. Now this is an introduction to polynomials, which kind of follows on to what we've been doing on quadratics, which followed on to what we were doing with linear equations. This is really the bread and butter of what Algebra 2 is all about. Now, the first thing we've got to talk about is what is a polynomial function. So let's start with the formal definition of a polynomial function. A polynomial function looks like this. We have p of x, which tells us the function of variable x, equals a sub n times x to the nth power, plus a sub n minus 1 times x to the n minus 1's power, plus dot dot dot, plus a sub 1 x sub 1 plus a 0. Now that's a really complicated thing. But what this means is that all the a's are simply coefficients. They're 5, 4, 3, negative 2, something like that. They might not be integers, but they'll be real numbers. And the exponents is an integer. So if, say, the first n was 7, then it would be x to the 7th plus some number times x to the 6th plus some number times x to the 5th plus some number times x to the 4th, and so forth and so on until you have something times x plus a constant term. So it's all we have is there's no fractions in the x, there's no x in the exponents, we have x raised to different powers added together. Now each of these separations, the a n x to the n for instance, that's a term. So they can have a different number of terms and have a different power. Okay, the biggest exponent in this list is called the degree. And when we write the exponents, when we write them in what's called standard form, you combine all the like terms and then you reorder it so that the biggest exponent comes first and the next biggest exponent comes second and then third and fourth and so on until you're down to the last thing you should write is the constant if it exists. Now, after we do that, we can classify these. So to classify by degree. So there's a degree and a number of examples. Remember, the degree, what we're talking about is what is the biggest exponent there. And if you look at the first one, there's no x, which means it's x raised to the 0 power. And we call that a constant. Then in the second one, we have 7x plus 4. So x is raised to the first power, but that's it, nothing bigger. That's linear. We dealt with that. This looks like y equals mx plus b. And just last unit, we dealt with these next ones. Negative 2x squared plus 3x. Well, the biggest exponent is 2, so that's quadratic. And then we have x to the third minus 3x squared plus 1. That's the biggest exponent is 3, so that's called cubic, right? Because if you raise something to the third power, you say it's cubed. Then we have fourth, 5x to the fourth plus 3x to the third, so forth and so on. But you're looking at the biggest exponent. The biggest exponent is 4. And the prefix we're going to use for 4 is like the same that you want to use for quarter. So this is quartic. And then we have 128x to the fifth, where there's only one term, but it's raised to the fifth power, and that's quintic, just like you have quintuplets. And these are all adjectives that come before a noun. So this is a constant polynomial, a linear polynomial, a quadratic polynomial, a cubic polynomial, so forth and so on. We can also classify them by number of terms. Now these are going to be nouns. So if there is one term, and we call that a monomial, right? Mono like monorail, 1. 2 is a binomial. 3 is a trinomial, right? This is not too difficult. They're all in the nomial. They all have the prefix that goes with the number. A 4 is called a polynomial of 4 terms. We don't rename it for 4 and 5. So anything bigger than 3, you just call it a polynomial of n terms, however many terms it has. So let's look at this. These are some practice problems we could do. If you look at number 1, what you want to do is you want to rearrange it so it's in the proper order with all like terms combined before you classify it. So in number 1, I would have to change the order for the terms because x to the fourth has a bigger exponent than negative x. So that becomes 5x to the fourth minus x. Remember, the minus sign always goes with whatever comes after it. So when I rearranged it, it would be 5x to the fourth minus x, and since the degree is 4, it's cubic. Since the degree is 4, it's quartic, and it's 2 terms, so it's a quartic binomial. On number 2, you have 3x to the third comes first, then x squared, and then negative 4x plus negative 2x combines to give you negative 2x. So it would be 3x to the third plus x squared minus 2x. That would be 3 terms, so it's a trinomial, and it's to the biggest degree. The degree is 3, so that's a cubic trinomial. Number 3, you can combine 4x and minus 6x to get minus 2x. So it's negative 2x plus 5, which is a linear binomial. Then you have number 4, where the 3x to the third and the 2x to the third combine to give you 5x to the third. So you have 5x to the third plus x squared minus 4x, and that's a cubic trinomial. And then finally, you have number 5, where you rearrange the order. You get negative 2x to the fifth plus 6, which is a quintic binomial. The other thing we're going to do today, and we can't really do it at home, and I won't cover it too much in the notes here because most people don't have calculators at home, and I'm not going to show you everything to do right now, is to take a data table and use that to model a function. So you would plug this into the stat menu of your TI-84. You would put x in for L1 and y in for L2. And then you could do different regressions. Now I showed a graph of the points and what the regression looks like. So if you do a linear regression, that's what it looks like. You can see the points that are from the table, and you can see what the line of best fit looks like. So you can see that it goes kind of in the middle of the points, but it doesn't really fit very good. It doesn't hit all the points, so it's not a very good model. So the linear model sucks. But what happens when we do a quadratic regression and then type that equation into y equals? Well, you get a picture like that, which is clearly also not very good. So we go one step up. Then we do the cubic regression. So you can see now that when we put in the cubic regression, it hits all the points. So that's a good model for our data. So we would use the cubic regression, and then you could go into the table for your calculator and see what x would equal, what y would equal if you made your x 25. And that's the kind of things we'll do with modeling. That was just a quick run through. I suggest if you weren't there in class or you're still lost on this, you should come see me in class or after school so we can actually we could do this with a calculator in hand. Okay, so that's what we're going to cover. 1, 2, 25, and 26, you need to use a TI-84. So if you don't have access to it, you really can't do those problems. If you do have access to it, please do them at home. Then 4 to 24 even, that's going to cover rewriting the polynomials in standard form, as well as classifying them by degree and by number of terms. Okay, good luck, and I'll see you in class next time.